So a while ago, I was fascinated by the idea of simple machines, in which you could take simple materials that are arranged somehow and perform a deep understanding about the phenomenon. I went online to discover what kinds I find interesting, and I found a video from Stanford that really hooked me. Call it the paper centrifuge. The video demonstrates the extremely fast spinning of the disc when pulled by two rods connected to fishing wire. They claim that it takes a budget of 20 cents to make using materials that can be simply found at home. The disc itself, when both rods are pulled, can reach speeds up to 125,000 revolutions per minute. I love the concept of speed for the disc, and that I always wondered why they could reach those levels. I wanted to make one of my own just to figure out the physics behind it. Inspired by this, I used the following materials: a cardboard disc, scissors, two toilet rolls, tape, and string. I cutted the cardboard into a circle that's about 4 inches in diameter and used a sharp object to poke two holes in the middle. Then I grabbed some string and poked through the hole. I looped it around the toilet rolls and repeated the process. I used tape to hold them together. This arrangement should be reminiscent of what Stanford showed the viewers. In theory, what should happen is that the number of twists correspond to the amount of pulling force, in that as we increase the number of twists, we also increase the pulling force. However, the distance between the disc and roll decreases depending on the number of twists. This would make it a little difficult to pull both ends, increasing tension, and if you pull the rolls, the string should unwind and the disc should spin. With that in hand, it should look something like this. So I decided to try this out in the hopes that I could get similar results. However, several problems occurred. When I pulled the rolls, it seemed that the disc stopped spinning. I also thought that whatever the number of twists corresponds to will be equal to the number of twists needed to continuously spin, which is why I attached a mass to counteract it. This didn't work either. I tried something else. So I decided to increase the diameter of the disc and add two buttons to it to increase the torque. If you paid attention, there are four holes present instead of two. I basically adjusted my centrifuge to include the two buttons plus glue, and it should look something like this. Instead of just manually rotating the disc, I decided to spin the disc at about one end of the roll. This yielded the same result. Even doing the method like before didn't help. I was in a rut about what went wrong with my invention, and after a couple of meltdowns and punching my walls out of frustration, I went online for help. I found a video from ThinkTech of how to construct a centrifuge just to see what I did wrong. I realized several things. This is polymer string. This is cotton string. The difference here is the material. Polymer strings are weak and thin, which I agree with because when I constructed it, it was very painful to put it through one of the cardboard holes. You could hear the sounds just to prove it. I opted for a cotton string because it was much better to handle and it's more efficient. Also, the arrangement for looping the strings was changed to better suit the increased speed for the disc. So I used this video as a guide in the hopes that this mechanical centrifuge would work. I removed the materials listed here because I don't really care about it, and the disc is what I'm most interested in. After trial and error, I finally got my results. So here I discovered that by pulling in the moment the disc reaches max speeds, you can hear that it formed knots on both sides, indicating that there's way more force of tension than unknotted. And here, pulling it yields an increased speed of the disc. In another view, you can see the disc in action. Here, I drew a dot to demonstrate its effects. The moment the force of tension is maxed out, the disc stops spinning for a moment. Here's that exact moment. You can see the dot becomes visible as the disc slows down. And here you can see the dot clearly. Once I pull both ends, the disc should start spinning again in another direction. It will oscillate with equal forces. I want to mention the distance between the disc and handle should be directly proportional to the pulling force and speed of the disc, and not inversely proportional. I played around with this for half an hour, and I was really happy this turned out well. I even broke the strings that were supposed to hold them together, but it wouldn't matter anyway. I got rid of the toy rope because it was simply to hold the strings together, which is why I used my hands. I hope this explains it. I'm reaching 5 minutes, so one thing I could learn from this is to try improving it little by little. And hopefully what comes out of that would be the result we wanted. Okay, I need to stop recording. This is taking too long. Bye guys, and wear your seatbelts.